Hi everyone, in this lesson we're going to be looking at some more differentiation rules. We're going to be looking at the derivatives of sine, cosine, e to the x, and ln of x. And don't worry, you don't have to memorize any of these. They're in your formula booklet, so let me show you that. If you're to go to topic 5 in your formula booklet under calculus, you'll see that these derivatives are here under SL 5.6. And of course, I had already showed you chain rule, product rule, and quotient rule are there as well. So you don't have to memorize them. They're right here as a reference. And so in the vocabulary, I'm just going over the natural log function. That's ln of x, just as a reminder. And that the domain of a log is going to be greater than 0. So this value right here always has to be greater than 0. And the derivative of sine is going to be cosine. Derivative of cosine is negative sine. The derivative of e to the x is just e to the x. And we'll look at a very short proof of why that is. And the derivative of ln of x is 1 over x. We'll do some practice now. It says find f prime of x if f of x is x times sine of x. Now you have to be really careful here. We have a variable times a variable. So we have x times sine of x. That means that we're going to need to use the product rule. So we'll call x f, and the sine of x, we'll call that g, and now we're going to use the product rule. And we'll just fill in underneath that. F is x, the derivative of sine of x is cosine of x, and the derivative of x is just 1. And that's it. Moving on to number 2, we have a quotient. I'm going to use the quotient rule. And now we'll fill that in. G is the sine of x. F prime will need to use the chain rule. This is the derivative of the outside times the derivative of the inside. F is 3x squared plus 1 to the 4th. And g prime is the derivative of sine, which we know is cosine. The next step, I'll just clean up the top. There's really not much we can do, but at least I'll multiply the 6 and the 4 and put things in a little bit better order. And that's it for number 2. In problem number 3, we're going to need to know the derivative of cosine. The derivative of cosine is negative sine x. We're going to have to use the product rule. We have a variable and a variable. So we're going to use a product rule. F is 3x squared. Derivative of cosine is negative sine. G is cosine of x. And the derivative of f is 6x. And there's really nothing I can do here, but I'm just going to neaten it up and put things in a little bit better order. And that's it for number 3. Number 4, we have a quotient. We're going to use the quotient rule. And we'll fill that in. The derivative of cosine is negative sine. F is the cosine of x, and now we're going to take the derivative of g, and we'll need to use the chain rule. So we have the derivative of the outside times the derivative of the inside. All over g squared. Now I think I'll simplify this. I'm noticing that I have this guy squared here. I have the same cubed, and then I also have that in my denominator. So I'm going to pull out a 4x squared plus 2x minus 1 squared and then rewrite my numerator, and that should help me clean this up a little bit. So let's see what I did. I took this out of this term. That means I still had a 4x squared plus 2x minus 1 to the first power, and I had a negative sine x. For the second term, I took this out, but I still had a minus 3 cosine x and an 8x plus 2. And then in the denominator, I had a power to a power, which means I used multiplication, and 3 times 2 is 6. That works out really well because now I can cancel some things. I can cancel this. That leaves me with 4x squared plus 2x minus 1 to the fourth power. All right, and one last time we'll rewrite this. So the main idea here is that you're able to get to this very first step. That's really the gist of this lesson. But I think it's helpful to see the simplifying. I mean, over time you'll get better at it. So knowing how to get to here is just really a bonus. Now we're going to use some derivatives that require us to look at the derivative of e to the x. And the derivative of e to the x is e to the x. And I have a proof here if you're interested. I'll go through it very, very quickly. If you remember when we did the limit definition of a derivative, we used the limit as h approaches 0 of the difference quotient. So we had this point, and then we distanced a second point on the curve by using the value of h. So x plus h is the second x value, and e to the x plus h would be the second y value in our second coordinate. And then we just apply the difference quotient. Remember that the derivative is the slope. So we're using the equation for slope as the limit of h approaches 0. So we have y2 minus y1 over x2 minus x1. That's x plus h minus x. That just leaves us with h. You can rewrite e to the x plus h as e to the x times e to the h. Then we're able to pull an e to the x out of the numerator, leaving us with just this guy. And because of our limit properties, we know that this can be out front. Now, if you examine just this, if you put 0 in, we're going to get 0 in the denominator. But if you were to look at the table of values for that function, you would recognize that this limit as h approaches 0 of that function is just going to be 1. I'll show you what I mean. So here I have the function. If we go to table set and we tell the table to start at the value of 0, so we can examine it around 0, and we want to look at values really close to 0. Now we're going to go to the table. And you can see that as we're approaching 0 from the left, we're getting closer to 1. And as we're approaching 0 from the right, we're getting closer to 1. So that limit is 1. So then we end up with e to the x times 1, and that gives us e to the x. So that's a very short, quick proof of why that is. I think the only reason I include it, because it does really confuse kids, so just sort of seeing it, talking about it, it might help. But just remember, this is in your formula booklet. So if you're being asked to find the derivative of e to the x, like number 5, the solution is just very simply e to the x. For number 6, it's really just as easy. We're being asked to find the derivative of 3e to the x. So that derivative is just 3e to the x. We like these, they're easy. Now for number 7, we're going to have to use the product rule because we have an x in this part and we have an x in this part. So we're going to use the product rule. Now we'll fill that in. G prime, we're going to use the chain rule. The derivative of the outside times the derivative of the inside. G is sine x cubed. And the derivative of e to the x is e to the x. It looks like I can very easily pull out an e to the x in both terms, and I can pull out a sine x squared in both terms. I'm going to do that and make this look a little nicer. All right, so you might argue with me that this doesn't really look that much nicer. The point of this lesson is that you're able to get to step 1. And if you can, and you simplify it a little further and rewrote it like I did in step 2, that's certainly fine. But either of those are acceptable. All right, moving on to number 8, we're looking at the derivatives of ln of x. So the derivative of the natural log of x is just 1 over x. So for number 8, the derivative of 3 ln of x is going to be 3 times 1 over x, which is just 3 over x. On this last page now, we're going to be using the chain rule for trigonometric, logarithmic, and exponential functions. So you have to be really careful with these. For number 9, we're going to be looking at the derivative of the outside. The derivative of sine is cosine, times the derivative of the inside, the derivative of 3x minus 1. All right, so let's write that out. The derivative of the outside is cosine 3x minus 1 times the derivative of the inside, which is 3. You can leave it like that. I prefer to write it with a 3 in the front, but either way is fine. Number 10, we have the chain rule now for cosine. We're going to be taking the derivative of the outside times the derivative of the inside. The derivative of cosine is negative sine. So here's the derivative of the outside. Now we're going to be taking the derivative of the inside part of that. And that's it for number 10. Now, chain rule for e to the u. Let's look at the rule here. You've got the derivative of e to the u. When we say u, we mean that this guy up here, the exponent of e, has a derivative. So we would write e to the u, but then we would, next to it, the inside part would be the derivative of u. The outside would be e to the u times the inside, the derivative of this. Let's write that down. So y prime is equal to the derivative of the outside, that's just e to the x squared plus 2, nothing changes, times the derivative of the inside, which would be the derivative of x squared plus 2, so times 2x. And that's it for number 11. Going back up to our rules here, we have the derivative of ln of u. In other words, if a value inside here has its own derivative, we have to remember to multiply by that after we take the derivative of ln of u. So it's the outside function, ln of u, the derivative of that is 1 over u, times the derivative of the inside, which is du dx. I'll show you what I mean. So y prime is equal to the derivative of ln of u. So in this case, it's going to be 1 over 2x squared plus 1 times the derivative of the inside. That would be the derivative of this, which is going to be 4x. And we would just write that as 4x over 2x squared plus 1. And that's it. Now these chain rule type questions for sine, cosine, e, and ln, they take a lot of practice. So make sure when it comes time to sit down and do the practice, you really go through these and get used to remembering that these all involve the chain rule. All right, everybody, that's all I have for this lesson. Thanks for watching.